Beautiful. So what I want to talk about today is really just kind of picking up where we left at the end of last term. So at the end of last term, we talked about reflections around an axis. And in particular, what we looked at was graphing negative f of x. And when we graphed that, what we discovered was that all our points, they reflected over the x-axis. So just quickly recapping that one. So what we have down here below is we have the graph of the function. Tell me some key features or some key things you know about that function straight away. If we look at it as f of x is equal to x cubed plus 6x squared plus 3x minus 10. What is something that we know about this function? Yeah, it's an, ooh. Be careful where we say odd function, Dave. David, remember that an odd function and an even function is different to something that's got an odd degree or an even degree. Yeah, we've got three intercepts. Polynomial degree thing. I think that's what you're referring to there, David. That it's an odd polynomial there. It's degree 3, which means we've got that Travolta kind of curve happening for ourselves. It is positive because it's going that way. We can start to pick off some other things. Its leading coefficient's positive 1, and it cuts through the y-axis at minus 10. So great work, guys, picking all that up straight away. That's awesome. Remember that when we are asked to sketch negative f of x, that just means all our coordinate points need to be reflected over the x-axis. So ways that we do that is, you can see I've just zoomed in there on the graph. You can see I've already highlighted a couple of points there with black dots. And what you'll do in your exam, for argument's sake, that first point up there, I know it has a coordinate point of, it's 1 point something, but it matches for a y-axis value of 11. So you get a ruler and just draw with your ruler, just hold your ruler down, and then you can put a point down at negative 11 and those 2 points and then exactly underneath each other. And you can do the same for every other point that doesn't meet nicely on an axis. Just get your ruler, draw down. So that one, I need to put a point at 5. Everyone's following that, just using our ruler to transfer our y coordinates from being a positive y coordinate to a negative. We're just swapping the signs of our y's. So if I keep going, this 5 here, it's now going to come up above. I'm swapping signs. That negative 10 there becomes positive 10. That's going to be just up here. 2 is going to stay the same. That point, which is just past it on 5, so just past it on 5. That's that point there where it's negative 3 point something and 10 point something. I would just use that point as that's more for us going to be more of an estimate. We know that it's going definitely pass at negative 4 and negative 10, but we're just going to curve just past that. That point stays the same, our x-axis, and that point then shifts up to 5. So now that we've got, that was some very large dots that I've drew. Now that we've got that, we're just going to kind of follow our curves along. Oh, that was dodgy. Oh. And we should end up with something along the lines of that. Does that feel familiar again from everybody from last term, where we just moved our y coordinates over the x-axis? Either they went from positive to negative or negative to positive. Yeah? Cool. So that's my quick, rough, hand-drawn version of it. And as I scroll through, apologies, that looks a bit chaotic. But the red line was our initial graph. That blue line was our negative f of x. And you can see those purple arrows there just showing that those points are changing the sign of their y value. Cool. So what I want to just jump into, just kind of refresh our memories. If we have some function, and I've called it g of x here, and it's x squared plus 5x, what would g of 3 give us? I'm happy if someone wants to turn their mic on and just to shout these ones out as we go. Well, g of 3 would be 3 squared plus 5 lots of 3. 24, thanks Ethan. G of 0, well that's cool. That's nice and easy. That one's going to give us 0. Now what about g of negative x? Yeah, x, ooh, it's going to give us x squared minus 5x. So what we're doing is we're substituting negative x everywhere that we see x. So negative x squared, because it was x squared, so wherever x was, there was negative x, plus 5 lots of substituting negative x. And we end up with x squared minus 5x. Now we've seen substituting negative x in before when we went all the way back early term 1, where we looked at testing if a function was an odd or an even function. When we put negative x in, for it to be an even function, what we wanted was to get the same original thing. So if this function was going to be even, we would have, this answer down here, this one here, would have been x squared plus 5x. It's not, so it's not an even function. For it to be an odd function, g of x would have needed to be equal to negative outside of. We need to be able to prove that it's that one. And if we have a look down at actually what we've got, I can't factor out a negative out the front of it all and get the original function left inside the brackets. So it's not an odd function. This one is, in fact, neither odd nor even. The only reason I bring that up, one, a little bit of friendly revision, and the other that we've seen substituting negative x in before. So trying to really clarify that when we sub negative x, sometimes there are two things we're asking you to do. One of them is, is this an even or an odd function, or neither? And what implications does that have of it? And I'll get onto what I mean by that in a second. Cool, so I'll leave that there. What I've done down the bottom here, I'm going to now continue that down to there. What I'd like to do, let's just fill these tables out here just quickly. And I want to see, and let's just compare these two tables to each other and see if there's anything that we notice about them. Cool, so table 1, who wants to have a crack at letting me know the answers to table 1 there? Cool, thanks Ethan. Minus 2 squared is 4, 4 plus minus 10. So we just got to be careful there. 4 plus minus 10, that should be minus 6. Minus 1 squared is 1. 1 minus 5 ends up being minus 4. That's going to be 0. 1 squared is 1. 1 plus 5 ends up being 6. And then, yeah, that one does end up being 14. So just be careful there, Ethan, with your negatives. I think you got caught up with your negatives there with the plus 5x. On the right-hand side there, if we compare these, minus 2 squared is 4, minus 10, so that's becoming 14. Minus 1 squared is 1, minus 5 lots of minus 1, so minus 5 becomes add 5, so that becomes 6. That stays as 0. What we can see here is 1 squared is 1. 1 minus 5 is minus 4. And 2 squared is 4 minus 10 gives us minus 6. Is that okay? Cool. Anyone describe for me what you have noticed? Compare the two. I felt very much like the Wiggles just then. Compare the two graphs, two tables, and can anyone throw out something there that you've noticed about those two graphs? Oh, not two graphs, two tables, sorry. It goes opposite ways. The tables are reversed, flipped. I was wondering what slipped was, Jack. Thanks, they are flipped. Yeah. And when we say flipped, is there a particular point that they're flipped around or reversed around or the opposite? Or it's inverse? Ooh. Yeah. Yeah, 0. We can see that 0, between 0 stayed in the same spots, and we've just traded everything there, the origin, the y-axis, everything's just traded places. And here is that, and what do we know about, well, I mentioned it earlier, 0 being the y-axis value. So here we can see points are just swapping sides over a y-axis. So if I scroll down the page, f of negative x is a reflection around the y-axis. It gives us a reflection. So negative f of x reflected around the x-axis, f of negative x goes around a y. And just here in that pinky color, I have written that we've used if f of negative x equals our original function, like we said earlier, that became an even function. And when we looked at even functions, we said one thing that all even functions have is that they're symmetrical around a y-axis. Now, why we've got that is over time, when we looked at substituting negative x into our function, we noticed this idea that the entire function flips over the y-axis. It's reflected over the y-axis. And that was pretty cool to us as mathematicians. But as we played around with different functions, we noticed that there was a special group of functions that when you did negative x, the graph didn't actually change at all. It just stayed exactly the same. And it stayed exactly the same was because the y-axis was an axis of symmetry for something like a parabola. When you flip the points around, it stayed exactly the same. And that's where we came up with the idea of an even function, that it's a very unique case that when we look at reflections around a y-axis. So because it was so unique and it gave us, and it allows us to understand a whole lot more about a function, we gave a special name to it, that if you put negative x in the function and you get the original function, that just means its axis of symmetry was the y-axis. It's a special type of reflection, so that's why we gave it a special name. Is that okay? Yeah, cool. So we have seen substituting negative x in before. So what I want to make clear, and some students last year made a mistake of, whenever we ask you to do negative x, they go, oh, you asked me to test for an even function. If we ask you to sketch f of negative x, we're looking for reflections. You use f of negative x to help test if something's even or odd or neither. Cool. However, not all functions are even, so we need to take care when sketching. I think I've just covered that. So going back, what I've pulled up here for you here is the function of x squared minus 2x. Hopefully that parabola looks pretty familiar to you, maybe, fingers crossed. It was the first example we looked at when we sketched things over the x-axis. Here, all we're going to do is we're going to sketch things around the y-axis. So, well, this point 4, 8, because it's going around the y-axis, its y-coordinate is going to stay the same value. So, what we're going to do, instead of having our ruler going vertically, you're going to have your ruler going horizontally through the points. On the page, you put your ruler across. And because it had an x coordinate of 4, we're then going to replace that position at the point minus 4, 8. If we go along, the next coordinate, which was 3, 3, we're now going to put it over at minus 3, 3. So minus 3, 3. The point 2, we'll undo that one. The point 2, 0, well, it's just going to go over and become the point minus 2, 0. The vertex of the parabola there at 1, minus 1 now becomes minus 1, minus 1. The point 0, 0 remains because it sits on the y-axis. Point minus 1, 3 becomes the point 1, 3, and the point negative 2, 8 becomes the point 2, 8. Can you see how all I've done is we've just moved points over the axis? Everyone's comfortable that they've just swapped over the y-axis. Yep. And exactly the same as before, kind of like back in primary school, we're just going to join the dots. Knowing that this is a parabola, our curve's going to have, literally a curve to it. And that orange line that I've drawn in there now is the graph of f of negative x. And that's the graph of f of x equals x squared minus 2x. Is that okay? Assuming so. The key feature to sketching your graphs and reflecting them across the axis is to take time, identify some coordinate points, and move them as you need. So here are some questions. These are, again, very familiar questions. Hopefully these are the exact same ones that we did at the end of last term as well. So again, doesn't matter what kind of curve it is, this is now just going to reflect across. So the point 1, 8 becomes the point minus 1, 8. The point 0, 2, well, it remains because it's on the y-axis. The point minus 2, 2 becomes the point 2, 2. So, and then everything just goes across. So something up here, what's that? It's going to be just, it's 20, about halfway. It's going to come over here somewhere, and we're going to end up with something like that. Is that okay? Yes, beautiful. Cool. Same thing would happen. We're just moving points to the other side and drawing our curve back in. Is everyone okay with those examples? Is everyone all right if I move on to something just a little bit slightly different now? Beautiful. Cool. So now that all seems pretty comfortable with people, we're going to ask you to take it to the next level. And what we can ask you to do is we can ask you to combine reflections. And what I mean by combining reflections is that we can go, can you sketch minus f of minus x? See how both reflections in there. The minus f of x gets us over the x-axis, and then there's the minus x inside the bracket, so that gets us over the y-axis. We can ask you to do 2 flips at once. Is that okay? Not that, maybe when I say is that okay, just the idea of doing 2 flips at once. It feels quiet, so I'm assuming it's not, I guess. That's where I feel people are like, okay, we can do two flips. How do you do 2 reflections? Well, you don't do them both at once. If you do 2 reflections, try to do 2 reflections at once. you tend to find yourself in trouble all over the shop, and it tends to be a mess. The best way to do it is to apply one reflection first, and once you've got the sketch looking like one reflection, then apply the second part to it. So I'll go through what I mean from that one. So we've got a function here of x squared plus 8x plus 15. It's a nice simple parabola, shifted left, polynomial degree 2, all that fun stuff. It's positive because the arms are up. Cool. And you've been asked to sketch negative f of negative x. So what you've been asked to do here by being asked to sketch negative f of negative x is to reflect it around the y-axis and reflect it over the x-axis. We don't care which order you do it in, as long as you do both reflections. So for me, how I'm going to tackle this one first is I'm going to reflect it over the x-axis first. So what I'm going to use some construction lines to help us do that. So very much the same as before. That point there at the very top, that 15, well, it's going to now become negative 15 because I'm going over my x-axis. This point here of, what's that going to be? That's 1, 2, 2, 2, 2, 3. I'm going to say that's now it's still going to be 2, but it's now going to be negative 3. The point on the x-axis stays the same. The vertex, instead of being -4, -1, it's becoming +1. That point stays the same. This point comes down here, and I'm going to get to my 15. And what I'm going to do, I'm just going to quickly draw this in as a dotted line. So I'm not too concerned about it being my final answer. This is only me getting part way to my answer. Is everyone okay with that? I haven't drawn it as a solid line because this is part of my construction, part of my idea of how I'm getting to my final answer. So when we think about this, what we've done is we've done that blue part. That's the blue is the negative f of x. That's our reflect over our x-axis. Now what we're going to do, and let's do that in dark green. No, not dark green because that's green. Let's go purple. We're now going to reflect it over our y-axis. So to do our complete options here. So the point 15, it's going to stay at 15, which is cool. What have we got here? That's -8. So this point here is -8, -15. It's going to stay -15, but it's going to go over to +8, which is here. And that's 2 across. So that's 2 across. That goes there. It's 1 past, so it goes there. My coordinate points were a 5 and a 3 and a 4. And what we're going to end up with is a curve that goes and there, our purple curve, sorry that I had my head down for so long, that's our reflection across both axes. And is everyone comfortable how I did that one reflection at a time? I did my x-axis first, got my construction line set up over my x-axis, and then I flipped it over my y-axis. Is that okay? Yeah? Anyone want me to go through it? I'll go through that very similar again. So, yeah, you go over one, and then you go over the other. And it's all a matter about taking your time, selecting a couple of coordinate points, matching those coordinate points where they need to be each time. It's all about being methodical as you go through it. Does anyone want another example, or are you comfortable? Yeah, another example. Cool. All right, so let's go to that cubic curve that we kind of had earlier. So that's the 2x cubed plus 4x squared plus 2. So again, I'm going to tackle this doing one step at a time. So I'm going to go back. I'm going to use orange. So my first step here, I'm going to, and I don't know why, I like flipping things over an x-axis first. It's just me. So the point 1 minus 8, it's now going to become the point 1 negative 8. The point 0.02 is going to become the point 0 minus 2, and the point minus 2, 2 is going to become the point minus 2 minus 2. And let's pick some other point. That point there is about halfway and halfway. So if I go to 20 and halfway, it's going to be about there. Where I've just drawn this one now, that would be the perfect time to use your ruler to line up points under points there nicely, so you've got an idea. Let's pick another point over here. What's one that you're about halfway? So if I draw a nice vertical line and you're 2 down from 20, so 2 down from 20, you're going to be there. All right, rub that out, and then so how does this line curve again? So it comes down. So it comes, whoa. So it's dot, 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 dot. So I'm coming down, so, and it went a little bit above, a little bit below. All right, cool. And that's just messy handwriting. Apologies, guys. So that one there was just my negative f of x. It's a really dodgy sketch. Apologies, but that you can kind of see that I've just reflected that over an x-axis. Now that I've done that, I'm going to send it over the y-axis. So kind of going to use the exact same points that I had. And I'm just going to send it over. So this point is going to travel to that side. That point is going to travel to that side. That stays still. That's going there. And that's going over to that side. Is that okay that now I'm getting that orange graph? That's my construction line. My first flip, I'm going to create a second flip. So you are about -4. So you were at -4, just in from -4. Halfway, so you're going to go there. You're at -2, so you're going to go there. You're going to set it, and you are going to come over. You're halfway, so you are going to come over to halfway. And you go halfway just before the 2, halfway just before the 2. And I'm going to rub out those arrows so they don't distract me too much. All right, here's the fun part. All right, so orange, that's going to come across here. So you need to come down here. Down here, you've got to go below 2. Or actually, that would have been a nice point to put in. Halfway in 1, halfway in 1. Up, down, and you kind of curve to there. And there we have it. Is that okay? It looks a bit messy. And as teachers, we're going to understand that your sketches are going to be rough. But what we're looking for is that you've got that general shape. And I think one of the things we're going to look for, and I'll highlight what's nice, let's go green, is that curve there. See how it kind of just floats above the line 2 and below the line 2? They're the kind of things we look for when we're going to mark. You know, is that floating curve there? You can see that see that this point here was getting steeper as it approached the line 2. So we're going, well, hang on, down here, did it get steeper as it approached 2? And then when that reflected over the y-axis, is it getting steeper as it approached -2? We're just kind of, that's what we look for. Those kind of things that kind of describe what the graph's doing at different point in times. Do they look like your sketch is doing that in the right section? Like you can see part of this original, it crosses over at -4 somewhere. So actually, if I was to think about that last section I just highlighted there at that top right-hand side, it's not exactly accurate. You can see in that first sketch down the bottom here, it does cross over the boundary of -4. My purple sketch, it hasn't crossed over 4. So what I should do is rub that out, and knowing that just after 20, it crosses over 4. So just after 20, it crosses over 4. So my curve should actually go along those lines. Does that make sense? Yeah. And again, when we come to marking these sketches, we're not going to expect you to have the curves exactly right. If you get the curves exactly right, awesome. Like, we're going to be like, as math teachers, we're going to be like, whoa, how good was that? That's awesome sketching. But we're just looking for, does it have the right shape? Is it flowing and curving? Does it kind of cross, different boundaries at the right stage? Is that okay? Cool. So just quickly to wrap up the reflections, that if you have negative f of x, that's something that reflects over the x-axis. And when you reflect over the x-axis, all your y coordinates change their sign. They change their sign. They go from positive, negative, or negative to positive. F of negative x, that reflects over a y-axis. And that's where your x coordinates change their sign. And finally, negative f of negative x, that's where you reflect across both. Cool. One thing I want to point out, and I'm just going to share a slightly different screen for you guys now. That's the one I want. Is with Desmos. So with Desmos, there's a parabola x squared minus 2x. That's one of the examples that we looked at earlier. With Desmos, notice how I've typed it in function notation. I went g of x. What I can do is I can say to Desmos, can you graph negative g of x? And there you can see it's reflected over the x-axis for me. I can ask Desmos to graph g of negative x. And there, let me turn off the one below. Here you can see that my x coordinates have changed their sign. It's been reflected over the y-axis. And finally, Desmos will graph also, both for you, the reflection across the x and the reflection across the y. Now, I show that to you as well. So as when you are going through and doing questions, if you're not sure and you know what the function is, you can type it into Desmos. And Desmos will help graph it for you, and you can compare your solutions to the solutions in Desmos. Any questions before we wrap up this afternoon?